A staggering 75% of electric vehicle manufacturers are expected to adopt either Celltopack or Celltobody architecture by 2025, with the global market projected to reach 10 million units by the end of the decade. To put this into perspective, in 2020, only 2% of EVs utilized these designs, demonstrating a significant shift in the industry. From a data analysis standpoint, Celltopack, or CTP, architecture involves placing cells directly into a pack without a separate module, resulting in improved packaging efficiency and reduced production costs. For instance, Tesla's Model 3 uses a CTP design, which has contributed to its lower production costs and higher profitability. In contrast, Celltobody, or CTB, architecture integrates cells directly into the vehicle's body, enhancing structural integrity and further reducing weight. The Porsche Taycan, for example, employs a CTB design, which has enabled the vehicle to achieve a lower center of gravity and improved handling. A key metric to consider when evaluating these architectures is the pack-to-body mass ratio. In CTP, this ratio is typically around 1.1 to 1.3, whereas CTB achieves a ratio of approximately 1.0 to 1.1. This translates to a 5 to 10% reduction in overall vehicle weight for CTB designs. Furthermore, CTB architectures often exhibit improved crashworthiness due to the more even distribution of cells throughout the vehicle's structure. According to the National Highway Traffic Safety Administration, a 10% reduction in vehicle weight can result in a 5 to 7% improvement in fuel efficiency, which is critical for EVs. From an expert insight perspective, Dr. Gregory Less, a renowned battery expert, notes that CTP and CTB architectures both have their advantages and disadvantages. While CTP offers improved packaging efficiency, CTB provides enhanced structural integrity. The choice between the two ultimately depends on the specific requirements of the vehicle and the manufacturer's production capabilities. In terms of production costs, a study by McKinsey found that CTP designs can reduce costs by up to 15% compared to traditional module-based architectures. However, CTB designs often require significant investments in manufacturing infrastructure and process development. In conclusion, the choice between Celltopack and Celltobody architecture depends on various factors, including production costs, vehicle performance, and structural integrity. While CTP offers improved packaging efficiency, CTB provides enhanced structural integrity and reduced weight. As the EV market continues to evolve, it is essential to consider these factors and their impact on the overall vehicle design. With the global EV market projected to reach 50 million units by 2030, understanding the differences between CTP and CTB architectures will be critical for manufacturers to remain competitive. Subscribe to Evtrix for real EV data every week.